Okay, so this is, I was going to say it's but it's yours. This is your parallel access shift register being implemented by my hand. And honestly, I'll take the free W. It's a free win on my end. After the clock, dealing with the clock this weekend, I need some wins in my life. That would make me feel like a real loser for a couple hours. But that one, that's not what we're here to talk about. It's come together real nicely though, huh? Get you hyped up for that recording. So what we have here is, I changed the names, but it's all the same. We have a 4-bit input, which you'll see from our constraint file is just the first 4 switches. We have load and serial in also being read as switches. And then we have the clock, which is actually being read from the board as the 100 megahertz clock right here. And that's going into your slow clock generator, except I edited it to have a different name. I copy pasted it from my lab. So it's anyhow. I also changed this from 100,000 to 50. Oh no, sorry, from 100 million to 50 million, just so we have a 1 hertz cycle. So what are we doing here, huh? That's a good life question. But what we're doing with this lab, or this assignment specifically, is anytime we get an update on the out clock, which is being updated once a second, on the positive edge of that, we're going to check if load is true. If load is true, we're just going to change move our inputs. Oh, sorry, I forgot to mention this is an output. It's the 4 LEDs right there. So all we're going to do is move our input to our output, straight move it. So, and we'll see what that looks like, but it's pretty much if switch 1 is on, LED 1 is on, and so forth. And then if load is not true, that would imply that shift is true, because it's the opposite of it. So when load's high, shift is low, and vice versa. And when that happens, we're going to set Q1 to Q0, Q2 to Q1, Q3 to Q2, serial in to Q3. And these are non-blocking, so they happen at the same time. Look at that. We learned, huh? Pretty good. So what's this bad boy look like in action, though? You might be asking yourself. Hold on. Well, it's going to shift. I had it on, but that's kind of what it does when it's... So right now, it's shifting in zeros, because you'll see our serial input is 0. But if I turned it up to... Let's turn that baby up to 11, huh? 11, huh? There it is. Boom. Look at those bad boys. Bright as the sun. It's a magic. Turn it down. Turn it up. Do whatever. Have fun with it. So it's just shifting whatever our serial input is across right now. Just because it's been so long, and it's updating once a second, like I said. So if I turn this to load, what we'll be able to do is just load whatever values we want in. So if I wanted 1, 1, 1, 1, bada bing. I can turn off the middle 2. And it updates on the positive edge, so, because it's just reading from the clock. Bada bing. And now, if I turn this off, you'll see it slowly shift across zeros, because that is what the serial port is, the serial input's reading. Yeah, and no matter what, when the serial input's on, these things can be low or high. I have 3 of them low, 1 high. It doesn't matter. It's just, it's shifting the ones across, so it doesn't really care what these things are doing. Yeah, I think that's kind of it. If we turn on load, it turns off everything. Doesn't matter what the serial input is. Turn all these bad boys high. Turn on the serial input as 1. Nothing matters. And we can also get fancy with the serial input and the shifting. If we put it high. Oops. I was like, why is that not working? Oops. Oh, there it is. Okay. Then low. And high. And then low, and then high. Yeah, look at that, huh? Have a little rave. That's pretty good. Yeah. So hopefully that shows my understanding of the board. Thank you for your time.